Welcome back to this new WeeW episode for the Python tutorial. Actually, in the previous episode for the STM32F1, we have been reading the data from the ADC and send it to the computer. And so far we have been using for the communication with the computer the very good edge term, but one of the things that really not easy to manage, it's not really data visualization friendly. So even like the minimum, it's just a scrolling thing. To a certain extent it's quite nice, but if you want to use more the data and to have something very interesting to read and to use it carefully, we need to go further and to make our own program using Python. So let me close this one, disconnect it, and open here the program that we are going to use to create within this video. So this is our program, and as you can see here, when I be changing and moving the potentiometer, the value is changing here without really impacting or scrolling, so I know exactly what is my value. And just to quit, I have to tap the key Q to leave this program. So, and also we are going to use some threading and some other cool stuff to make this one happen. So if you'd like to learn more, just stay tuned. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment, or subscribe and stay tuned. This is the WeeW, and you are going to learn how to read data from the microcontroller using Python. So as usual, the code is available on GitHub. The language we are going to use is only Python, and the code editor will be VS Code. Finally, I think even if you have a beginner level for Python, that would be very fine, but if you are intermediate, it would be very easy for you to get it. For the hardware that we are going to use, so this is as a follow-up for the STM32F1 tutorial series that we do have on the WeeW, but if you do have even an Arduino, that would be totally fine, and we are going to use here the STM32F1, or aka Blue Pill, and also an FTDI to allow the UART communication between the microcontroller and the computer. Finally, you will need, whatever the microcontroller you do have, a variable resistance or a potentiometer to make the readings and to play with the readings to see how dynamically your readings are appearing into your computer. So for the tutorial, first of all, we are going to have a quick circuit and program review. Then we are going to get the serial data, the basic stuff. After that, we are going to build the cursors. Yes, not the cursors that you know in English, as I was surprised, but this is like a base core library in Python. After that, we are going to use the exciting stuff, the threadings, and to have the readings and display. Finally, making everything beautiful and make a right sampling and have a beautiful view. Okay, so the circuit that we are going to use, first of all, we will need a microcontroller. We have to connect it to the potentiometer, and you have to be sure that you have selected the right pin that has an ADC on it. After that, depends on the microcontroller. As we are going to use the STM32F1, we will need to have FTDI to establish the serial communication with the PC. However, if you are using the Arduino Uno or even Mega, you will not need this FTDI, and you can go forward without it. The message that we are going to use to send you through the UART will be the voltage measure that we are going to get through the ADC, plus a new line just to make this simple for the Python to read it. For the program, a quick review. So this is the program within our PC. There will be two stuff: the main thread, which will manage the user, something very easy and simple, just quitting the program. There will be like a message: if you'd like to quit, you just push the key Q. And the secondary thread, which will be getting the data and displaying it. And why we are doing like this is because we need the main thread just to handle the user when in the background, in a different thread, a program that is going to run everything, so there's no any interruption or any problem happening. So let's see now together, and let's jump to the code. So this is the first part where we start reading the data, the serial data from whatever the microcontroller, not even the STM32F1, but also Arduino or whatever the PIC. So what we have to do first of all, this is to install the PySerial library. So it's quite simple and easy. Let's just copy this one and pip install PySerial. So I just pushed it here, already installed it, so no need to stop there too much. And after that you just have to import serial, and that's all. So the magic is quite easy to make. Port, I will call it like COM3 would be called port. Do not use a magic number. And then let's have a ser, or the serial connection that we are going to use. It will be serial dot serial, and we are going to put, so the port I'm using is the COM number 3, so that's why I'm using that port. And the connection at the end of my microcontroller is the 115,200, and I will use a timeout of equal 0. Okay, timeout equal 0. After that, what we need to do is quite very simple. I will put a while true here, and then we are going to read the data. So data will be equal ser dot read line, and this is what this command will read the whole message until it goes to the end of the line. This is how it works. It make it very easy. And just to let's get the, call it a data sensor. I know it's a weird name, but anyway, and it will be equal, so what we need to have is data, the data what we read, and we have to use a decode. This one is to make it as a normal format for the Python. So we are getting from something sent in binary or something based on char numbers, and we would like to have it in a normal string, and this is what we are going to use, UTF-8. Okay, and after that we print our data sensor. Okay, so let's save and run this code on the just a moment, Python here, and yeah, I'm running this PySerial threading, and by putting enter I should see some data. So now I'll be playing with the potentiometer. You'll see the number. So we are reading the data, but the display is quite really not good, and this is not helpful at all to read the data and to have a comprehensive visual or friendly visual job. But at least we established the connection. So let me make a Control-C and stop it, interrupt it. It's really ugly, and we are going slowly, step by step, correct this one. Okay, so this is the first part. Now we can jump to the next one. So in this part we are going to start improving the display, and we are going to use this library, the Windows cursors. If you are using a Linux or Mac or whatever else than Windows, so this is a library that you can use within inside Python. But if you use Windows, you have to install it again, so you have to make a pip install Windows cursors. So if I put in, I already installed it, so no need to wait for that. Okay, so what we are going to add now is import and cursors. Okay, and after setting up the connection, let's first initialize the cursor, the screen that we are going to use. So generally speaking, this library is something that you would like to use if you would like to control the terminal and to have more graphical display inside your terminal, to have a more control on it. So what I have to do first of all is to create a screen here, and I will add cursors and init screen. This is what will start my terminal screen, and after that I will have to refresh. I usually do it, so for this one, refresh. Okay, so and to display there is a lot of function, but there is one that I usually use because it's simple and quite intuitive. So let me create row equal here 0, so you can easily understand the meaning, and column equal to 0. So we are going to add, so in the screen here, and we are going to put add string, not end string, but string here, and this is the row and this is the column, and let's put here value or data. Okay, so in total I'm adding 1 2 3 4 5 6, so 7. Okay, so when I'm starting using the cursors function, I can't use any more this print, so I will going to comment it first, and we are going to read the data, and we are going to start displaying it. To display it, then what we can use is go in here, and instead of data we are going to put data sensor. Okay, but for the column, as we would like to have display in front of column, so we are going to add here 8. So from the column 8 position, the 8th position, we start displaying the data, and we have always not to forget to add this refresh. Actually this refresh can be here, that would be better. And then let's copy again and we do have our refresh, so that should be fine. But what I would like to add is, before having this, let me copy this one, and having a small, make like this, so it will erase the previous data just in case the numbers, the total number of digits change. Okay, so this is the cursors, it's just controlling the cursor's position, and also having, you can add some coloring to this one. Okay, so let's save and go to the terminal and run. Okay, that's not the right place, so cd this one and Python. Okay, so you see here the number is changing a little bit, but that's not as we would like. Another problem coming from the cursors library, and you maybe notice it if you are following the code and trying to execute at the same time, is when you put a Ctrl+C and you'd like to leave this function, you are not able to do it because the cursors disable this kind of function that can interrupt the code. So one of the things here is to just shut down the terminal, and I have to run again, so I go to open integrated terminal again. So the reading here was not really successful, so what I can do is just putting like this for the moment, and I show you why I added this one. So if I put Python here and put the code, okay, there's something getting wrong. Python is not recognized, yeah, of course, because it's not, yeah, this is not a Python. Okay, that should go now. Okay, I didn't save, that's my bad. Let's go back again. Yeah, this is one of the problems of the cursors library if not used in the right way, and we are going to do it in the next part of the code. So as you can see, I have something crashing. It's quite consuming in time and sometimes frustrating, so let's just wait a little bit. And VS Code is not really so responding with this terminal thing, so let's just wait a second. Okay, reopen. Perfect, so I will save this one, so we're removing this one, and we should, let's open this one in a terminal and putting Python and the code. Yeah, a little bit of improvement, but you will see, so it goes to almost the 1000, the maximum value, but when we try to go to smaller values, something like a 0 or smaller, there is some residual data that stays there. Let me go slowly, and still here it's not really very beautiful. Yeah, it works quite well. Yeah, you have an image, but this is really still fuzzy, and we cannot cancel what's going on. So in the next part we are going to improve this one. So we have being able to draw some data on the screen, but still something not really helpful to get out of the screen, and still not good enough. So what we are going to do now is to have a kind of main thread that will control like what the user would like to use, and another thread that we are going to create which will be in charge of reading the data and display it in the screen, so the user can really, like, all the program can focus on something and the other thread will be doing something else. So first of all, we need to create a function that will manage all this reading the data and displaying. So what we are going to do is just come in here after this one, and we put def here and we call it my serial, for example, and and this is what we can do. So we just put this while here, and also what we can do is to add even this one here, so the whole function will manage the serial stuff. Okay, so why this went like this? Okay, so we do have the whole serial managed now, but we need to have also another control on this one. So we do have while true. Let's create a variable, like a global variable here somewhere. I'll call it global, and let's call it global is correct here. So let's call it serial. Now let's call it UART just to avoid any misunderstanding, and we add another one the other side, so for here, and we call it global, global, and we call it UART, and here we say UART is equal to true. Okay, and global UART, and while UART, we keep running and doing this. So this is the first part. So after that, we can start creating the mainstream, the one that would be interact directly with the user, and this one is while true, and we have to read something as an input. So to read the input using the cursors library, it's a screen, and we are going to use get key, so to get directly the key. Okay, not k, let's put it equal to key, better. And if key is equal, let's say if the user will type, let's say the letter Q, then what will happen, UART will be equal to false, and we are going to break and exit the program. Okay, so that's how the code will be working. However, in this situation, so even if I run my serial here, one problem will happen. So the first one, if I run my serial in this way, it will be stuck here without going to this place. And the other problem then, if we put my serial somewhere here, the program will be waiting each time for this screen get key. So what we need to do is to work on a threading, create a threading that will manage this one. And to do that, so we have to import threading, and we start working and create a threading. So let's work on that. So first of all, we have to create, like, let's call it T1 and equal threading dot thread, and we're putting the target equal my serial here. Where is it? Yeah, and it should be after the main program. Okay, and we are going to add something else, this T1 dot daemon, and this is if there is an interrupt or something happening, equal true. This will help to manage a lot of things, because when you have a threading running and you interrupt, like you interrupt your program, this threading will help you to survive and to kill also the other thread. Else you will have some troubles and this thread will not stop until you crash your terminal. And finally we are going to run and start our threading. Okay, t1 dot start. Okay, so these three functions together will manage a parallel job doing the reading the data and displaying it, where here we do have some kind of a daemon that will help to interrupt if there is an issue. Let's add some indication here. So let's add something to this one saying row +3 and column 0, insert Q to quit, for example. Insert Q to quit the program. Okay, that should be fine. We can now start and run it. Actually, this is not the one that I want to go for. This, and here there is, we put Python and we can have the program. Okay, so you can see now, so I'll be moving a little bit the sensor, so we are reading, there's no issue at all. And if I put quit, it closes the program without any issue. So this is really wonderful, because I have two threads working separately and doing their job. So if I show you again, so you see here the number displaying. It's not really perfect, but we do have something that we can read and we can work on. And in the next step we are improving the display, but the program now where we would like to go is working quite better. So before to finish that, so let's close this one and manage better the thread. So the way that I have been managing here this thread is a little bit not the ugly way, but this is something that we are sure to make. But even with this one, I would like to add few stuff, so to really close this thread once for all. And to do so, I'm importing the signal library. Import signal. You can skip this one, but this will make your program really clean. And also import system library. Okay, so what we are going to do on this one is to create a signal. So signal here again, and we are going, if there is any interrupt of whatever, so just in case there is an interrupt happening, so saying int, so this is for the, if there is any interrupt, int this one. Let's have a signal handler just like this one, and this is the function that will work when we will need to it, when we will have this interrupt. Okay, and for this signal handler, so signal handler, we are going to put this inputs, signal and the frame. So what we are going to input on this one is quite to have a system exit, and this is where really clean the whole thing. If there's any problem, anything additional, this is really will clean everything and will not leave your system messy. Feel free to not add in it, but quite advise you to use this one. So let's run again to see if there's no issue at all. Yeah, so I can change the value. I hope you are able to see it. It's really small, apologies, but this is the terminal, and you can see there the value here. Okay, so this is a step where we worked more on the system structure, and now we are going to improve the display. So now that we have a better visualization and reading, let's improve a little bit the accuracy and how this program can work, and the added value of having other data coming to Python. So first of all, let's go inside the my serial here and add three variables. So the first one will be called the average and equal to 0. Sampling, which is the number of sample that we would like to have. Let's put 200 for start and see how things goes. And sample will be equal to 0. Okay, so now each time that we can read the data, so we don't do it like exactly, so let's remove this one and let's work on this. So first of all, when we read the data, let's check if the len of the data that I'm reading, let's put here, is greater than 0. So if it's not greater than 0, we don't need to read this one. Okay, and to proceed with the rest means there's nothing inside the system, the buffer of the UART communication. And so we can start there. And after that, so we read the data here, and as we are getting just the data or the information, what we can do is, instead of having the decode here, what we can do, we added a try here, and we move this one because we are going to make things a little bit more correct and robust. So accept pass. So we can put another thing, but here instead of putting the decode only, we can put it as int. So we are reading exactly the integer from that. And after that, what we are going to do is putting average is equal, or just be like Pythonist, plus equal sensor. So it means the data sensor. Okay, so it means I'm increasing the average each time, and sample will be equal sample plus 1. So plus equal 1. Okay, so and then what we have to do is say if sample is equal to sampling. Okay, so if we do have this equal to each other, we can start displaying the data. So let's move this one like this, and what we can do at that time is to say, so if we have the sample equal to sampling, we put, so first of all, let's create a variable, we call it sensor. It will be equal the integer of average divided by sampling. Okay, so actually it should be average, let's put sampling minus 1 because we are not, okay. And after that, so by doing this one, so screen equal this one, actually not, sorry, we don't need to put the minus 1 here, as we put the plus, so int of this one. So after that, so we had our sensor, so we need to add now, so average is equal to 0 again, so restarted, sample to reinitialized equal to 0, and from that we can add some stuff here. So what we can do, so let's go here and put screen, add how to put it now, I think we can add it here, so screen, and we can correct it later on, add str, not n, str, and we put as usual, so this is row and call plus, let's say, yeah, let's say 50. I'm not sure exactly, but let's put like this 8, and then what we can do is to put some spaces here and add millivolts. Okay, and in this one, in the data sensor here, we are not going to use data sensor anymore, but what we are going to use, f sentence, which will be the int, let's put this one, so it will be the int of the sensor multiplied by 3.3 volt, and that should be fine. So what we are going to do here is to have 200 reading, and this will be much faster because we are just going to read. We are not going to go inside this one, so because the display itself takes more time for the microprocessor of the computer, so we are really reading more and doing a lot of internal job that will not take that much time and not make the buffer quite overflowing. And then when we have a sample, we are going to display it. Okay, that should be fine, so we can save here and quit, go back again and see. So we do have this one. Looks, I'm moving now the potentiometer, and you can see that the value is changing quite well and quite stable. I don't have any variability. The only thing that's still a little bit not really beautiful, so what we can do, we can add here and add screen here each time, and we put, instead of row 0 we were putting row 1, we put nothing, just an empty stuff, just to make it clean. So let's try it. So I'm pushing Q to quit, entering again. Yeah, now it makes more sense. So like what I can do is just a 0 here. I think that will make much less trouble, and you can see now. So you see it's a very beautiful, very clear way to display in the terminal. It's not really very beautiful, but it's very easy to read data, and you can see it's a millivolt, so you can see how many millivolt are applied between at the peripheral for the ADC that we do have at the STM32F1. Okay, that was the last part. So we do have a reading from the terminal in a very friendly way. Hope you enjoyed this WeeW Python episode. See you for the next one. WeeW!